today I'm going to present about supersymmetry. And in the presentation, I'm going to talk about two main questions. First, what is supersymmetry? And second, what does supersymmetry theory explain? Here's the definition of supersymmetry. In particle physics, supersymmetry is a proposed extension of space-time symmetry that relates two basic classes of elementary particles: bosons, which have an integer valued spin, and fermions, which have a half-integer spin. Each particle from one group is associated with a particle from the other, called its superpartner, whose spin differs by a half-integer. Supersymmetry is a special type of symmetry in physics, which implies that there is a correspondence at a fundamental level between those two kinds of particles. Here's a short video to show you guys what supersymmetry is.
Physicists like to understand everything about the physical universe. We've come up with a pretty good theory that does a pretty good job. This theory is called the Standard Model. Using a handful of particles of matter and a few forces, we can explain an awful lot of what we see as we study matter and energy, space and time. However, the Standard Model is not complete. There are questions it doesn't answer, and so we continue to try and find better theories that explain even more. An idea that is often tried is one that we call supersymmetry. And I'm going to tell you what supersymmetry is all about. In a single sentence, a supersymmetric theory is one in which the equations for force and the equations for matter are identical. Well, you might wonder why this is a good idea. It turns out that if the world has this property, you can explain many mysteries. Before we talk explicitly about supersymmetry, I need to clear up a common misconception. Supersymmetry is not a theory. It is a principle that a theory might have. As I said, supersymmetry treats forces and matter on equal footing, and any theory with that property is said to be supersymmetric. Let me emphasize that point. There are dozens of supersymmetric theories, and they're all somewhat different. This is a little subtle, so let me use the idea of the principle of charity as an analogy. There are many ways to be charitable. An example of three different kinds of charity might be the approach where one works directly with the poor, or a rich philanthropist, or even my buddy Eddie's latest scam. If we found that one was ineffective, or even all of them, we wouldn't have ruled out the idea of charity, just a specific approach. Similarly, even if scientists rule out a particular supersymmetric theory, it might be that some other theory that treats matter and forces on equal footing is right. Disproving specific supersymmetric theories is possible, but to rule out the general principle of supersymmetry itself is actually quite difficult. So let's take a look at how supersymmetry shows up in...
Hope that gives you guys a broad idea of what it is. So, to explain what supersymmetry really is in one single sentence, a theory is supersymmetric if it treats forces and matter on equal footing. So basically, supersymmetric theory categorizes the world into two categories. Like one is like matter particles, which stand for fermions, and one type is called force particles, which stand for bosons. Matter particles actually builds up everything we know, and it gives you guys structures like bricks. Force particles, it intends to act in a different way, and it does not actually give the structures, so we cannot see them. Right? We can feel the power of force, but we can never see the force. Symmetry means that if I make change, the final result remains the same. For example, a sphere looks the same no matter how I twist it in different directions. In physics, we think in terms of mathematics. This simple equation, 3 plus 4 equals to 7, which we all know that. And when I swap the order of 4 and 3, I still got the answer equals to 7. So I call this equation is symmetric. In particle physics, much more complicated equations are used. This one. This equation is the standard model equation. It governs the behaviors of bosons and fermions. Let's make it easier for us to understand by applying only the key features in the standard model equation. The basic equation is shown here. Equation equals force particle plus matter particle. And let's swap the order of matter and force. We will see that only the position of matter and force are switched, but not the color. So the second equation does not actually look identical to the first one. So it's not symmetric. But when I add the superconductor, which is a new pair of matter and force particles into the equation, into the first equation, and then swap again, we can see that these two equations become identical. So this is the essence of supersymmetry. A supersymmetric theory is one that treats matter and force identically. This is the most useful takeaway message. So what can supersymmetric theory explain? First, it can explain why Higgs boson has its mass. And second, force unification. And third, it provides a candidate for dark matters. The Higgs boson is a detectable signature in the Higgs field, which is an energy field to give fundamental subatomic particles their mass. The problem is that it is hard to understand why the Higgs boson has the mass that it has, because the quantum mechanics for most reasonable value predicted by standard model for the mass of Higgs boson is really large. The supersymmetry is real. One of the effects that can cancel out the huge mass seen in the traditional theory. This leads to a prediction of the mass of Higgs boson that agrees, which has been observed. For force unification, for example, let's imagine these two following phenomena: a dropping ball and the motion of the planets. These two phenomena seem to be unrelated until Isaac Newton realized a single force of gravity can explain these quite different phenomena. This different phenomena have a single explanation called electromagnetism. Similarly, scientists have reasons to believe that the three forces at the atomic level might be different aspects of a single unifying force. The strength of these three forces, electromagnetism and strong and weak nuclear forces, varies with energy. So, by using the standard model, we can predict how the strength of the three forces change. We can see here very high energy, they become similar, but their strength never becomes the same at a single energy. But when doing the same exercise, includes supersymmetric theory, they actually unify to a single strength at a single energy. There is no specific reason why the universe must unify the forces at a single energy, but it is rather alien. And this is one of the reasons that scientists find supersymmetry to be attractive. Next, let's move from microworld to the cosmos. Astronomers have long known that the galaxy is spinning fast and has its own mass. To solve the unknown problems in the universe, the scientists proposed a new kind of matter called dark matter. The difficulty is that we actually have never directly observed the dark matter. However, remember the supersymmetric theory predicts a series of particles that are the constants of the standard particles. The latest of the supersymmetric constants, called latest supersymmetric particles, or LSP, has the right property of the missing dark matter particles. So if supersymmetry is proven to be right, we'll be able to solve both cosmos and subatomic mysteries at once. In conclusion, there are over 10,000 scientific papers devoted to supersymmetry theory, in spite of having no direct experimental evidence saying that it is real. So far, nobody has discovered any supersymmetric particles. It is pure theoretical thing, and Optimus says that we have seen half of the particles, which are matter particles, and we are just waiting to find the other half.
Yes, go ahead, please.
Sorry, I didn't really get like the topic, but if you say that 3 plus 4 equals to 7 and 4 plus 3 equals to 7, if the result is the same, then why do you have to like switch it? Like if you say like after like the supersymmetry thing, like the result is the same, then why did you have to like switch the
Well,
two?
it's different in particle physics, right? For this one, I only swap the order of 4 and 3, and in particle physics, I have to swap. I have to add some new thing like, for example, this is like also add partner
I
a new
think what
partner.
he's saying is, I think there are two questions here. One is, why do you need to, thank you, babe. Why do you need to switch them 4 plus 3 and 3 plus 2? That's what she's asking. And the second question, which is related to what she's asking is from me, is, like you said, equation is equal to force plus matter. What does equation mean? Like, what does equation mean? Force plus matter has to be equal to something, right? I don't understand this equation. I think that's the problem because this one follows the 4 plus 3 is 7. Is that right, Cecilia?
Yeah.
So what does this whole thing mean? That's what I think is not very clear to us. And why did you show this equation? Like, all of these are connected, right? But I don't think the clarity is there about the thing.
Yeah, because
So
this
could you explain that?
because this one is for standard model equation, but
Okay.
it's too hard for us to understand.
That's fine.
So I,
But what do these mean? That's what we are asking. We are not showing back that that's what very tough for you to understand, of course. But you stated equation is equal to forces plus matter. What does equation mean? What is equation? And why did you say force plus matter? Because it's not about force plus matter, right?
to make them
Sorry?
to make this symmetry.
No.
You were saying that we had to equate force and matter. That's what the guy was saying that they was.
But in order to do that, we have to like add something more to the equation. Compare the force and matter.
So this is the basis actually. So it is not about equation. I'll explain it very quickly to you. It is not about equation equal because equation means nothing, right? It's not about force plus matter. It is about that whatever you think about in terms of forces, like when you learn dynamics, and whatever you learn about matter, they are all unifying at some point of time. And that happens because of the supersymmetry in nature. You see what I'm saying? So whether you look at the forces or you look at matter, they all unify in one place. Like energy and matter is one, right? It's the same, it's similar to that. Does that make sense now, Ian? So it's, the equation doesn't mean, that word doesn't mean anything there. And it's not force plus matter at all. Where did you get that equation from then?
I